Good day, everyone, and welcome to today's SecurityBoulevard.com webinar. We're excited that you've joined us. Our topic today is achieving the optimal application security posture across the enterprise. Very timely topic for these days of COVID and work at home and all the things that are happening, changes that are happening in our world. Today's webinar is sponsored by Signal Sciences. My name is Mitch Ashley, and I'll serve as your host and moderator. Just a little bit of housekeeping here. We are recording this webinar and we'll send all participants an email with a link to the recording as well as slides. We're also giving away gift cards. We'll have 4 gift cards, $25 each. We're going to give away at the end, so stick around to see if you've won. We also really enjoy questions. We'd love to have your questions, especially during the talk, and there'll be a demo and all throughout the webinar, so feel free to put your questions into the questions tab of the GoToWebinar software. So let's move on to our topic, achieving the optimal application security posture across the enterprise. It's my great pleasure to introduce Daniel Hampton, Senior Technical Account Manager with Signal Sciences. Without further ado, take it away, Daniel.
Thanks, Mitch. Appreciate it. It's a pleasure to be here. It's very good to talk about this topic with you guys. Also a pleasure just getting to know you a little bit right before this. So, as he said, please, if you have questions, I don't want to kill anybody by PowerPoint slides. So, and my voice can turn into a monotone when I'm boring myself. So please don't let that happen. Ask questions, and I'm happy to field those. So, let's talk a little bit about this. So, achieving application security posture across the enterprise. So today we're going to talk about a few things. We've already done this. We're going to get into the modern app landscape, what things look like, the challenges that we're faced with today, and then we're going to talk about how we can use Signal Sciences and other security tooling to meet those challenges. Because as much as I would love to say that Signal Sciences is a tool that can absolutely do everything better than everybody else, that's not the case. It's never going to be that way. You're always going to have an integration between teams. You're always going to have an integration between tools. Where we try to shine is exactly there. We try to make sure that your tools and your teams can collaborate to provide you with an optimal application security posture. So we're going to talk about how to effectively detect and block a variety of web application security type vulnerabilities, threats, etc. So a little bit about me. I have been doing this for a while, to the point where I feel like I'm starting to get old. So I work with the enterprise customer accounts at Signal Sciences, and I do some overlap into the mid-market as well whenever I'm needed there. But largely it's the big guys, big customers, large numbers of employees, huge numbers of different teams and silos are aplenty. So very familiar with all those challenges. Also with the need to move a little bit more progressively. Take your time to make sure that everything works before pushing it into production. Just doing it live doesn't always work, but with DevOps, that's changing, isn't it? We're going to talk about that. So prior to being at Signal Sciences, I worked largely in the database security world, and I worked actually for Imperva, a competitor of Signal Sciences. But I largely worked in securing databases, and there are quite a few challenges there. Everybody hates data breaches and doesn't really enjoy their free credit monitoring. So that was a pleasure to work there, and I worked with some really good guys there, and an excellent team, good product, had fun there too. So moving here was a shift, and working in the web application security world and seeing just how much we're into containerization these days was a lot of fun. So anyway, prior to that, I actually ran a company that provided managed services to SMBs. So I think our biggest customer was around 500 employees or so. But so I've actually done the full gambit. I've worked for the little guys all the way up to the big guys, and I have seen the challenges inherent to all the different types of structures. And I have also worked across the database team, dev team, platform services, system administrator. I've worn just about all of those hats. And My least favorite of those is doing coding and direct software development, although I do like working directly in the software development lifecycle, and especially have a lot of respect for developers. Um, I'm glad you guys do your job so that I don't have to, and I'm very, very happy that our tool makes it easier for you. So working in security is definitely been the highlight of my career, and I plan on staying here. I plan on sticking around in the web and database security spaces for quite some time, maybe far into my retirement. So what does the modern application landscape look like? We used to be monolithic largely. I remember back 2010, oh gosh, you know, anywhere from 2007 up to about 2012, we saw a huge amount of virtualization taking place. So VMware was a massive player, and everybody was playing around with virtualization. And then it seemed like overnight, things switched to containerization. Kubernetes just came up out of nowhere, to me anyway, it seemed like. And we started just segmenting everything out. And I'd worked with, I actually had several of my own monolithic apps that I had developed and built and was maintaining, and it was such a pain. So when we started segmenting things out, it was a challenge because learning Kubernetes and containerization was, and Docker and all that, it wasn't natural for me. It took me some time. I noticed the development mind seems to pick it up faster than others. But once I got into it a little bit, I saw the strengths, and I saw that if you do have the technical expertise to manage it, you can do some things that you just can't do in the monolithic world. So I tend to get ahead of myself. Apologies for that. So monolithic architecture, almost everybody in the enterprise now is using containers in some way, shape, or form, but it's usually hybridized. You still have a smattering of monolithic apps and people struggle to convert over to microservices type applications, and people are trying to get into the cloud more for the inherent advantages that we don't really need to cover given the audience, and you guys know the strengths that you have when you've got distributed architecture and you don't have to manage quite so much because things are, you've got your own microservice, you've got that handled and you know everything about it, and as long as you keep your service working, the other teams keep their services working, you've got a product that consumers can enjoy. But everybody's moving to that. We've just seen it over and over again over the years. So on the left, you see just the basic monolithic app where everything was all in its own, business unit. And then on the right side, you've got everything's owned by a different unit, and it's, you're collaborating together over APIs. This is really common now, and that comes with a couple additional challenges. It solves some problems and creates others. So when you've got, it used to be that the topic of east-west traffic wasn't really much of a thing. It meant one monolithic app basically making an API call to another monolithic app. Now that's not the case at all. Almost everything is just back and forth between your microservices. So securing that east-west traffic is something that people have struggled with, especially using legacy WAFs. And especially given architecture like this. So I don't know of any applications that are broad consumer facing that are not using some form of CDN, WAF, load balancer, gateway combination. And then the application sits behind that with its own assorted technologies. There are a tremendous number of those, Istio, Ambassador, you've got Pivotal that's trying to provide the basic platform so that you don't have to. You've got all kinds of different things at play here. So WAF struggle in this, and security struggles to not just understand the requisite technologies, they struggle to make the case for making changes in a way that doesn't kill the business and that doesn't kill the development team, and it becomes a very adversarial relationship I've seen, which is a huge shame, because security should be there to serve the needs of the business and to make your jobs better and easier, because you're not having to worry about some things that really are better suited to another team. You can just do development, but that doesn't happen a lot of times because we've got a lot of false positives. We're shutting down production traffic, and you also don't have a whole lot of understanding between teams. So big challenges. When it comes to COVID-19, that introduces even more challenges. So this is kind of our timeline. From left to right, you see September 2015, Signal Sciences started taking web requests for our customers and protecting those. And I wasn't anywhere close to Signal Sciences at that point. It's funny thinking back through this timeline where I was. Then you've got, if you look all the way to the right, you can see February 2020 when a major shift happened. So we saw our traffic go up, I think it was 27% just in a month. So this is, that's a significant jump, right? Everybody started working from home. People scrambled to meet the needs associated with a 100% remote workforce, which very few organizations were used to. Now, Signal Sciences, we didn't have a whole lot of changes because we were already almost, we had local workforce, but I mean, myself, I've been to the office just a handful of times, and most of my coworkers are all remote. So a 100% workforce is something that was very natural to us. And so supporting additional infrastructure for that wasn't something we had to struggle with, but we saw everybody else just scramble with it, and it was tough. So moving forward, when it comes to your application security teams, your dev teams, and your remote workforce, and how to collaborate together, right, to solve these problems. How do we handle all this, right? So when it comes to containerization, this is kind of a segue slide here, but it is important to note. So you've got, this just kind of highlights the prevalence of containers and how the enterprise and even the mid-market is leveraging Docker and Kubernetes to solve their monolithic management creep, I like to call it. And just everybody is going to it if they're not already. Almost everybody's split though. They still have some of both. In terms of how to do this, right? Large enterprises, you've got applications and APIs, and they're running in the same place, or they're segmented all over the world. And usually it's both. That scale has a massive attack surface. And you don't just have to secure your client to server communication. Almost every one of your servers is now also its own client, right? You have your APIs from different microservices hitting each other. This is all traffic that has to be secured or that can be exploited. So I get the question all the time, especially in the enterprise. How do we secure our APIs? We get that you guys help with web application security, but what about APIs? What about APIs? How do we secure those? The answer when it comes to Signal Sciences is the exact same. Right? We secure an API just like we secure a web application. The traffic is going to look a little different, but the idea is to provide a baseline of security that does not need to be tuned. It doesn't have a tremendous amount of false positives, so that when you've got DevOps going on and you have weekly code changes and you have people moving all over the place, you have a monolithic app that's being converted into AWS or Azure or Google Cloud provider, and you have people shifting CDNs all over the place. It's almost like a BYO CDN, right? I've seen that. I have one customer who, based on the visibility that our tool provided them when we were doing their deployment, they noted that one of their web applications had 6 CDNs, all just lined up in front of each other, doing a variety of things. And it turned out that there was a merger that had taken place, and one org just brought theirs with them, and they were paying for 6 of them. They had no idea why. The security team was just completely in the dark, and traffic was in so many layers. It was really tough for them to figure out what was going on until they had our tool in place. It made it very clear to them. So they wound up solving that. They still have a variety of CDNs in place, but they don't have as many because they didn't need it. Okay, which goes to vendor sprawl, right? So in Perv and F5, you've got them. Traditionally, we were in the data center and we were sitting in line. You've got a CDN that's running somewhere else, right? And then you've got a cloud solution where people are evaluating a variety of frameworks, technologies, and providers. So a legacy WAF, it does a pretty good job, generally speaking, of covering OWASP top 10 type vulnerabilities or injection type attacks, but attacks are changing all the time. And now we're seeing very dominantly in this space, we see credential stuffing, we see account takeover, bots are all over the place. I don't remember the number from last year, but it wouldn't be relevant this year anyway. I'm sure it's gone up dramatically, but it was in the 20% of all malicious traffic was bot. Or maybe it was 20% overall traffic was bot. I don't remember what it is, so I'm just going to go ahead and back out of that for now. And it's changed now for sure. I'm sure it's increased. But we see it all over the place. We see bots hitting applications, and some of them are just, they're benign. They're just, crawling or just taking a look at your site, indexing, whatever it is they're doing. But it's not an attack. It's not a malicious or an adversary. But we still have to know what's going on. And it's nice to know when a bot is hitting you, especially if you're used to seeing customer traffic only. So categorizing bots and figuring out what to do with that traffic has been a challenge. Then you've got your API abuse and DDoS, which has been around for quite some time and is continuing to be a major issue. And then operational complexity. You've got code changes happening constantly. So how do you handle with a traditional legacy WAF that relies on regular expressions to do its job? How do you handle these massive changes to a code base and also to what the web applications are seeing? Because oftentimes we create a web application with one thing in mind, and then the traffic that we see shows that it's being used in unexpected ways, or that it's being exploited in very unexpected ways. So gaining the visibility and then being able to provide feedback to the development team from security, or just have a direct line to development so that while development is taking place and testing is being done, because a lot of people are testing stuff, they're testing stuff in the cloud and it's live right away, right? Because it's not meant to be live to the consumer, but as soon as bots sniff and get a hold of what's going live, they are going to hit it with traffic, which means you can help developers test their product a lot better if you can give them a single pane of glass visibility into what's happening. So all of that's a challenge that we aim to solve. And then when it comes to security engineers, people are always strapped. They do not have enough. And getting that total cost of ownership down to where you're actually seeing value from the product, but you're not just spending all day tuning it or fighting between security and dev to try to get your applications to work, but also be secured, but it's not working, but it's secure. But okay, you've got to get a good handle on that, and it's very expensive to do any of those things. So what do some of these look like, right? So account takeover, not assuming that everybody knows what all these are. Account takeover and credential stuffing are fairly similar. Basically, you see situations all the time where databases are hacked. People lose the entire volume of their credentials, billions of accounts, right? And then people just take the passwords and those credentials and they just hammer your web applications to get in and then do a variety of things. You can do business logic attacks. You can do credit card enumeration once you're in an account. Or you could have an account that is just created by a bot for the purpose of credit card enumeration. It's a valid account. I have one of my customers struggled with that. And so we had to, instead of just rate limiting their logins, we had to see once a login took place, what was happening against the API that was being used for credit card validation, because people were using that API to test a bunch of stolen credit cards and try to push things through. Once they were able to get one validated and pay for a membership, which was very small, then they would take that and use it elsewhere to purchase a lot more stuff. So rate limiting stuff like that, rate limiting different countries that we don't do business with, that's a big one. And then also the communication between your layer 3, layer 4 firewall and then your layer 7 firewall. So that can be a challenge as well. You can do rate limiting at the edge more effectively than you can at layer 7, but you need to have some communication for that to take place to gain the visibility. It's another thing that we aim to solve. And then you've got your CVEs, right? You've got those coming out all the time. And what if your application can't be patched right away? What if it takes you time? What if the development cycle doesn't really allow for updating to the latest version of Go or Apache or Nginx, and you have to test things first? Meanwhile, you're vulnerable. So you've got to figure out a way to solve those issues as well. We call that virtual patching. What we aim to do is to simplify all this. We don't want it to be constant tuning. We don't want it to be constant conflict between your dev and your security team. We want visibility without hassles. And we want the things that we're blocking to be real attacks every time, if we can, right? So those are kind of the goals. And that is why Signal Sciences exists. In terms of what it does and the feature set that we offer. So the buzzword, right? Next gen WAF. What's the difference really, right? Between that and a legacy WAF? Well, it's the approach. It's the approach. Layer 7 WAFs have been around a while. People have been doing a variety of different types of controls for quite some time. But the way a next gen WAF works, and in addition to the functionality that a legacy WAF provides, is the flexibility of deployment and the API. Let's see, what's a good word for that? The flexibility that you gain through a rich API set of functionality, and the ability to install on the application itself so that you can't be bypassed. Legacy WAFs used to just sit out in front. That's great if you have ingress and egress controls, but if you do not, or if they're not perfect, or if you don't want to trust them, and should you ever? No, right? You should have layered security or defense in depth. And having a RASP or a WAF or layer 7 firewall that is sitting on your application that can be deployed as apps are being built and scaled up dynamically, that's very much a need in the DevOps space. You want to deploy your apps quickly. You want to make your code changes quickly. And you want to make sure that there's still a baseline of security and that you have complete visibility into what's going on. So that's where installing at the RASP level, really the difference between a RASP and a WAF, as far as I'm concerned at this point in our technology, and when I say our, I mean collectively all of the RASPs out there, is that it captures traffic at the application level. So an application sees traffic, and as it sees traffic, we see the same traffic and we get to make decisions on it, right? The speed at which that must take place is obvious, especially to developers. If you are adding even a couple of milliseconds here and there, that can be a problem. So what we aim for is sub-millisecond response times for each request. If we're going to sit in line, kind of a need. And you can't do that with regexes. You have to do it with something else. So that's why we built this, and we built it differently. We'll get into that in a minute. So BotSense. BotSense is a relatively new offering with Signal Sciences, and it's designed to do exactly what we talked about earlier, categorize and show visibility into bot traffic. We are called Signal Sciences for a reason. We add signals to interesting traffic. So if we see something where we've got a 401 or a 404, that's interesting, right? Somebody could, if we're getting a 401, somebody could be trying to just hammer your application with a bunch of usernames and passwords and hope they get lucky. So if we see thousands of those, we probably want to start rate limiting that, or we at least want to make somebody aware that it's happening. Because another challenge is we know how to solve account takeovers and credential stuffing. We know what to do when credentials are stolen. The real solution is to put something that can't be stolen in front of your apps, but it's costly to do that. Multi-factor authentication is a very good solution to those issues, but people, especially in the e-commerce side of things, they know how impatient consumers are. They don't want to wait around for this stuff. And setting up two-factor, if everybody was doing it and people understood the need, it wouldn't be a big deal, but it can be difficult to rationalize this to management. You have to have data. And if you can see that you're being constantly hammered with account takeovers and credential stuffing, that can be a very compelling reason, especially when you can demonstrate to management the cost of not having a multi-factor solution in place. Another solution we aim to provide. And then we have advanced rate limiting. So we try to provide not just the capability to rate limit specific endpoints and types of requests, but based on our API, we try to be able to get that data out and quickly push it to the edge so that it can be effectively done outside of your app. Because obviously, if it's hitting your app, it's costing you something. It's even if your vulnerabilities are controlled, you still have to deal with the performance hit that comes with thousands and thousands of hits on your app. So we want to do that as far out as we can. So we provide that visibility in addition to a layer of defense in depth with some advanced rate limiting at layer 7. Then we've got our API protection. So when I talk about API protection, I want to talk about inter-service communication, providing east-west traffic protection versus just the north-south client-to-server protection. We definitely do that because we can sit on the application itself, especially if you're in Kubernetes and we're sitting there as a sidecar off of all of your services. We see all the traffic that's going in between those services. Or if your ingress provides all of the routing, we can sit at ingress and provide the same function. Account takeover protection, we talked about that. DDoS, so we've partnered with some people in this space to make sure that we can provide you with DDoS protection as well. And then gain visibility to let you know that this is indeed happening. In terms of how this works and the integrations that we provide so that DevOps teams can see visibility using their tools instead of ours.
I'm sorry, Dan, while you're talking about this, we had a question from someone asking, could you explain east-west protection?
Absolutely.
Really well.
I'm glad you asked because you know what? I tend to, if I think in buzzwords and they just make sense to me at some point, I forget to explain. So east-west communication. So consider north-south. Actually, let's look at so if you look at this slide here, if you look on the right where you see internet and then you see your services, that's the service layer is supposed to represent whenever you see those APIs and you see Signal Sciences little shield icon sitting there in the middle of that little box. So I consider north-south communication to be from a client, meaning public, internet-based traffic that is inbound to your service, right? And then a response out to that client. That is considered north-south communication. In terms of east-west communication, that is communication within your network between your microservices, and generally it happens over API. So say you have multiple microservices that perform different functions. You've got a print function, you've got a billing function, you have a credit card processing function. Well, each one of those provides completely transparent functionality to the web application that is being served to the client. So, but you still have to secure that communication because people will exploit it. And if you don't know how microservices are directly communicating to each other, especially in DevOps, right? So if you have microservices that are architected originally, especially with turnover, right? People move, people leave their jobs and they move to other organizations, or they move within the same org to somewhere else. It's difficult to keep track of how these applications are communicating and what that communication really does look like. Because if the API function is there, doesn't mean everybody knows it, doesn't mean everybody's using it, only some devs are going to be. So gaining visibility into how all those services are communicating, and then also securing that communication against the different types of attacks we're talking about. That is what I mean when I say east-west communication. Hopefully that makes sense. If it doesn't, please ask. And I'm happy to provide more clarity on that as much as I can.
Sounded good to me. Thanks.
Right on. So in terms of your integration, so everything that you see on these slides, we have either a direct relationship with those providers, and we work to make sure that we can give our customers a seamless integration, or we already have something that is just complete. It just works out of the box and it'll work directly. So if you've got Nginx, Kubernetes, Azure, Java, Chef, Ansible, all these technologies, you can deploy and actively run Signal Sciences and then get data out into whatever tool you're using very easily. Just reiterating stuff here. So we've already talked about how to do, or the challenges associated with this sort of environment, this varied environment. We have tons of technology and all sorts of different tools in place. We don't want you to have to use our UI. We want you to be able to use our UI and whatever tools you want. We want you to be able to get the data out of our tool and handle it the way you've been handling things so that you don't have to learn something new. But at the same time, we want to provide you with something where if you don't like your existing solution, you don't like your SIM or your management console or whatever it is that you've been using, you have something very simple that can be understood quickly. That is one of my favorite things about Signal Sciences. Our training course takes me 4 hours to deliver, and that includes a 2-hour lab and QA. 2 hours to go through and teach an entire tool that has loads of functionality is just, in this industry, I don't know of any other technology that is this fast. Splunk training takes forever. When I was delivering Imperva, it used to take me 2 days to deliver half of the training, 3 days for the other. These are complicated tools, and our engineers have done a fantastic job of making our UI user-friendly and concise, but not sacrificing a lot of the visibility and functionality that is required. So I love that. Just quick plug for our engineers there. And in terms of the tuning, you don't have to do it for the baseline of security. And for development and security teams, this is massive. And they don't believe us. They don't believe us. We'll come in and we'll say, listen, we want to deploy in prod. They'll be like, sure, we'll get right on that. Let's do it in a test, like a little lab environment first, and see how bad you screw things up first. What they wind up doing, and this is awesome. I've never been in another company that does this. So our sales engineers will go in, they'll do a POC, and by the time they're done with the proof of concept, they're in a prod app somewhere in blocking mode. We have 90+% of our customers are in blocking mode because you can, and you don't have to shut down. You don't, I mean, you can still worry about it, but you don't have to worry about shutting down your prod traffic because of the approach we take. We don't block all traffic. We block malicious traffic. So if you got some guy in Starbucks and he's using a shared IP with 50 other people, and all 50 people are just browsing your site, you're having a good day. They're all watching television, and you guys had a killer Super Bowl ad, and they decide that they're going to log in, and everybody's checking your site at once. And then you got that one guy who decides he's going to use that opportunity of high traffic to exploit you and attack you. We're going to be blocking him, but we're not going to be blocking the others on the same IP address, which is why organizations trust us so quickly. They get buy-in with the development teams very quickly, which is, it's always a challenge with security doing that. Okay, so we've talked about kind of how things work locally, but we haven't actually gone into the architecture very much. And we've definitely not talked about how data enrichment takes place in the cloud. What we want to do ideally is not just protect your web applications with what's hitting you, the traffic that's hitting you. We want to take all of our customer base and grab data that can be used to enrich all of our customer base. What does that look like without compromising the data? Whenever I say things like that, I can feel the hairs on the back of my neck kind of go up and go, oh, great, Signal Sciences is taking all of our data, and what are they going to use it for? We can't trust them with that. So the only thing that we're doing is we take a look at what malicious traffic is hitting every customer. If there is malicious traffic, if we see 50 attacks in a minute from an IP, then we add a little signal that says SigSci IP. And that signal is passed to all of our customers so that they can decide better what to do with attacks that are coming to them. Or just look at that traffic and say, you know what, I don't know what this is anomalous. We're seeing a bunch of 404s from this group of IPs, and it has this SigSci tag on it. And we don't have any URLs that are directing to the one we're seeing here. We've checked for bad links and stuff like that. So what's happening? Well, they're probably just hammering you, trying to find URLs, for admin sites. They're doing some forceful browsing or whatever, or they're trying to just enumerate your entire site and then do some kind of business logic attack. You don't know. So you have to be able to get additional context. So we try to provide additional context doing that. And in terms of how we eliminate these false positives and how we do things quicker, how we keep it sub-millisecond. Now, again, not all things are sub-millisecond. If you have a huge, massive request coming in, it could take a little longer to process, but the far and away, the average that I see is sub-millisecond at my customers. And that's what we aim for. We aim for really sub 2 milliseconds, but in the real world, largely I see below 1 millisecond for a decision. And the way we do that is by using our proprietary SmartParse. So we're not doing any kind of regexes. We do have the ability to do that if that's just something you want to do, or if and there are some times where it is better to do that. Different workloads require different approaches. But in terms of your web injection type attacks, your OWASP top 10, it's just more efficient to do it the way we do, because we don't see false positives, and we have billions of requests per day that validate that in production, so that our customers can trust us to eliminate their false positives and stop shutting down their production traffic. We talked about Cloud Engine a little bit. Okay, we didn't talk about fail open design. So if you've got this tool and it's sitting in line, because it is, how do you guarantee that stuff doesn't get shut down if say something goes wrong with this agent, it fails open. We have two components. One of them is the module. The module sits on your code layer or on your web server layer and captures the incoming traffic, and it sends that to the agent for inspection. If the agent doesn't respond quickly enough and it is a configurable threshold, then the module just fails open. And there's no moving parts to the module. It's just, it's incredibly simple. The agent does all the heavy lifting. So if our agent does, for some reason, crash, which definitely we don't want to do that, but we have to plan for it to make sure that we're doing our due diligence, traffic's still going to pass. In terms of flexibility of deployment options, this is major for people as well. So we see people say, can we deploy at our web server? The answer is yes. Can we deploy at Node.js or Java? Can we sit on Tomcat? The answer is yes. Can we deploy out front of this legacy application that we coded in-house and has absolutely nothing in common with anything else except that it's processing HTTP, WebSocket, or gRPC traffic? The answer is yes. We can use a reverse proxy for that. Another additional gain there is if you have a legacy application that you can't keep up to date and you're using a vulnerable web technology, you can put a reverse proxy in front and you gain a Golang web server that is kept up to date. So some of those CVEs we were talking about can be mitigated there, like the HTTP request smuggling vulnerabilities we saw back in the fall that were killing everybody. What about containers? You can sit on those too. I've got customers actively using Docker Swarm and Kubernetes to orchestrate and handle their containers. And I'm seeing the push has been so pronounced that we now maintain our own container with an agent in it so that you can more effectively deploy alongside your app. We've also got service mesh. We've got platform as a service. I mentioned Pivotal earlier. We've got your API gateway that we can deploy at. We can deploy on the load balancer most of the time. The point is here, if you want to protect it, we want to provide a deployment option that works for you. And in terms of, if you don't want to manage the infrastructure at all and you don't want to even think about installing our agents and modules, we can do a hosted cloud WAF for you as well. Okay, talked about this. We are going to be providing the slide deck later for your review if you'd like. I want to get through it so we can show you a little bit of a demo and take a lot more questions. Please, though, don't hold questions. If you've got them, please ask them now. I would rather spend time answering those. Cloud native application protection, all these technologies, we built integrations for these.
Hey, Daniel, there are a couple of questions I want to highlight here. One
Please
of them
do
is
ask.
how relevant is this for the cloud, a la Azure or other services? The other is, where in the infrastructure do the agents, are they installed? On servers, WAF, routers? Where do those go?
Okay, well, hopefully those have been languishing for a while, and we answered at least that second one with the deployment options. Anywhere. The answer is anywhere. You can deploy this anywhere. That is one of the major differentiators between us and our competitors. If you have something that we can't deploy in, we can deploy in front of it. And if that's not an option, we'll build something that works for you. But 9 times out of 10, we've already got something out of the box that's just going to work. We probably have seen your technology before with our customer base, and we probably have something that works right away. In terms of how this functions with the cloud, that's why we're here. That's why we're here. We're here to secure cloud applications. That's largely how we got started. So a lot of the smaller customers, they don't have a lot of the monolithic apps. They don't have their own data centers. They're heavily using AWS. They're heavily using Azure. We've got integrations with Kong that work, for example, if you wanted to provide protection for Lambda functions and things like that. If you've got stuff that is sitting or serverless applications, we're actively protecting loads of those right now because people come to us with that question all the time. How do we protect our cloud applications? Can you do it? The answer is yes, we absolutely can, and that is why we've designed our product the way we have. If that doesn't answer your question, please let me know, and I'll go back to it.
Yeah, I think that question was asked because Azure and services like that have their own WAF and DDoS and services like that.
They do, and we still work with them. So sometimes we build integrations directly with the cloud providers. Other times we just sit on the technology. Since I mean, if you're using Java or something, most of the time you're in the cloud, you're using a technology that is in the cloud. Since we are a RASP, if we need to be, right, we can sit directly on whatever technology that is. So in fact, I can't think of a single customer that I have that isn't using some combination of cloud technologies and it doesn't have us in place because we can't do it. It's that's why we're built the way we are. And so if you look at the second bullet point on this slide, increased flexibility to deploy layer 7 protection in cloud native applications. That is what we're here for. So okay, how this looks. So hopefully this slide also provides some clarity to that question. If you look on the right, you'll see the integrations that we have at the platform. Then our service mesh integrations as well. API gateway, we talked about that. Cloud WAF, we can sit in front of stuff. And since we're in AWS, anywhere AWS has a region, that's where we are. So if you don't own your own infrastructure, we can protect you. If you do, we can protect you.
We did have one question about Istio, since you had that on the slide. The question was, does Signal Science rate limiting services integrate with Istio?
Yes, it does. So in terms of how the implementation with Istio works, it's a little complex and would take us significant time to get into from a technical perspective. But we have built from the ground up, we've built an Istio integration that works seamlessly to scale and protects actually not just HTTP and HTTPS traffic within service mesh, it also will protect additional types of traffic if you need to, for example, WebSockets and gRPC. Hopefully that answers that. If not, by the way, we have public facing documentation that I'm going to get into in just a few moments. If we have the time, hopefully. If not, it's going to be associated with the slide deck, and you guys can get into it and see exactly how all of these integrations work. We have how to deploy in each one of these scenarios on our public facing site. Hopefully that helps. If it doesn't, please get in touch with us. We're also helpful we're happy to help you through any of these. Okay, so we've already talked about all this. Feedback loops, we've talked about this as well. Our goal is to make sure that security is visible to everybody using the tools that you already have, and keep the development teams, the security teams, management all aware of the challenges that you're faced with and how we're solving them to give you real world value. And then consistent sharing of data, kind of the same deal there. So this is an example. So we can send data directly to Splunk. We have a little Splunk app that you can install, or you can just use our webhook to get the data out of there too. But this is actually showing real world data coming into Splunk from our tool. So when we say API first, that's a big deal too. Anything that you can do in our UI, you can do with our API. It is designed explicitly to allow that. So if you see functionality, you can programmatically do the same thing. So you don't have to use our UI ever if you don't want to. And I actually have a customer who never does. They have everything scripted out. They're using Python and Go to do everything with Signal Sciences, from deployment all the way to getting visibility into their tools, and they use Splunk heavily. That's big for them too, because correlation, they're doing a lot of correlation from all their different security tools in Splunk. And so if they had to just get into our tool to get the data out, that'd be a problem for them. So this way, it's all in the same place. Their data is enriched all throughout the layers of their applications. In terms of the types of signals and visibility that you gain, right? If you're looking at this slide and your development, almost all this makes sense to you. These are things that security generally wouldn't know whether or not they needed to be interested in, but development is going to. Also, based on the signals and the way we show this to security, it gives them an idea of when to ping the development team and ask for a little more help, or say, hey, by the way, you guys forgot to change that password, and this API is hitting this API with a few 100,000 401s a second. Might want to change that. This has happened too. Any of these things that I'm bringing up have happened. Okay. And that would be considered a critical issue. You'd want to know about that right away, wouldn't you? And then sharing the data. So I have one customer who, the security team, they grab everything and puts it in Splunk, but the dev team doesn't have a SIM. And so they use our tool to gain visibility across all their applications. And they log directly into the tool and they look for things like this. Also, we provide a lot of performance metrics for not just our tool, but for the application server. So if you want to see how many milliseconds we're adding to a request, we show that, but then we also show how many milliseconds the entire request is taking and how the CPU looks and how the memory usage looks. We show a lot of stuff. Getting into all that today, we're just, frankly, we're not going to have the time, unfortunately. Okay, we've talked about these. Every single one of these, I have an example, and please do reach out if you're looking for how we solve for these. Because of the limited time, we have real-world examples of how different industry verticals have solved for every one of these problems using our tool quickly and effectively. This is an example of how our bot sense looks, how it categorizes bots, and how you can see the traffic, how it looks when bots are accessing your site. You can see kind of random stuff, then you see these spikes that look about the same every single time, right? And then you can also look down there and you see the signals and payloads towards the bottom of the screen. That shows, remember that SIG-SAI IP signal I was talking about? That means, like, there's no red signal here, and there's no direct attack that this is providing. But SIG-SAI IP indicates that that IP has indeed attacked one of our customers with a minimum of 50 attacks in a minute. So that makes this 404 a little more interesting. We're probably going to do a little bit more of an investigation to figure out what's happening here. So we talked about this. This is in a nutshell, right? We want to be able to protect any application from any type of attack, and we want to integrate with any tool. We don't want to force you to use us. Okay, so largely we've talked about all this. If you guys have any additional questions, please ask those right now. I am going to fire up a quick demo, spend a couple minutes going through that before we run out of time here.
Yeah, let me jump in with a couple questions. How about integration with Cloud Security Hub, such as Azure Security Center? There was also another question about the API Hub, I believe, in Azure.
Yes, so actually let's get directly into that. So there are times where we've been able to work. So I have a customer who, they use a very well-known SSO provider, and this SSO provider enriches login information from their security tools and then passes it along before allowing, for organizations can make a decision on whether or not they're going to allow somebody to log in. and access their tools. That customer reached out to us and asked us if we could provide the visibility that we're giving, because it wasn't doing well enough for them, and they had Signal Sciences and they'd seen us mitigate the same attacks, but they wanted it to be done elsewhere. They wanted it to be done at the edge. And they asked if we could get the data out of our tool and provide it to their other provider so that they could enrich that data. So we did that. You can pull, that's where the whole API first thing comes in. The idea is to be able to pull everything. If you see something in this tool, we want it to be accessible to your other tools, right? So in terms of what we see, and please, I think there was another question and those are two questions there. Please, did I answer the both or just the one? What was the other one?
API management, Azure API management as well as
Okay. So in terms of that specific API, I have not directly worked on that. None of my customers have asked for that, so I can't say comprehensively, of course we do, but the answer is almost always yes. Meaning, and I'll show you how it works. How about that? That might answer the question. So taking a look at this, we can see, this is just the dashboard page. It shows an overview of the types of attacks that are happening. We do not have tons of time, so we're just going to go quickly through this. This just shows an example of the different types of threats that we aim to protect against. In terms of your integrations, so if an API can ingest JSON, right, we can integrate with it. And if it can't, we probably have a tool that either in the services side or in the sales side we have built that can get the data out, transform it a little bit, and then integrate with the API in question. So we've done that with, I've worked with a variety of CDN APIs to do that, and then just building things programmatically as well. A lot of different technologies have been requested for us to hit with our APIs and get the data out, push to those, right? So there, we have I have very good confidence that yes, we can. I just have not personally done it. Hopefully that answers your question. So an example of this. All right, so here's some of the direct integrations we provide. The generic webhook is the catch-all, right? So if there's something that you have coming into our tool and you want it to be pushed to another API, we use our webhook to post that data, right? And the format that we're sending in is JSON, which is something that almost everything can take in. Logarithm has a little bit of trouble with it, but from my experience, almost everything you can get it to work. Just takes a little bit of effort sometimes. In terms of the data that you see, we went over that. This is something that we've only got a minute or two left, so I want to focus on this. So in terms of when an event is happening, when something is attacking you actively, how do you get this in a visible format that everybody can understand? If you just take a look at this, you can see how we make sense of things. This shows a timeline of the attack. When it started, how many requests we saw, what user agents was marked as suspicious with login attempt, right? So somebody is doing something we're interested in. We haven't decided whether or not we're going to block it yet. Oh, it breached a threshold. Now we're going to start blocking requests. This is in the case of login attempt, this is more of a rate limiting rule, right? We're rate limiting attempts to log in to this from this IP. And then you can also view the request directly if you want to see exactly what it looked like. Please note that we add request headers to these requests so that your application teams can actively do things with the data that we're providing before it goes back to the customer. Customer doesn't see this, you guys do. So you'll see the agent response, whether that's a block or an allow, and then you'll also see the reasons why in this X SIG sci tags. And then if you want to see the types of visibility that we provide out of the box, we can do anything, right? But out of the box, I encourage you to take a look at our public documentation. So this, got tons of it. And this is an example of some of the data that you will see for each request. We are out of time.
Yeah, I definitely encourage folks to check out the website. You've got some great information available there. I think would help a lot of folks interested in the product. Well, thank you, Daniel. That was awesome. Great job. Appreciate you taking the time to talk with everyone today. We're getting out of time. Let me just wrap up quickly. Our 4 gift card winners are Jocelyn H., Mike S., Steve H., and Tony D. for those Amazon $25 gift certificates. So we'll be reaching out. And also there were a couple questions, Daniel, that we didn't get to, so I'm sure we'll be able to reach out to folks separately and follow up.
Absolutely. Reach out to us anytime. We're happy to field those.
Great.
My pleasure to be here. Thank you.
Well, you know, it's a special day when we have a speaker who has a Pink Floyd t-shirt on. So thank you, Daniel. Daniel Hampton, Senior Technical Account Manager with Signal Sciences. Thank you, everybody, for spending your hour with us. Your time is valuable, and we appreciate it very much. Have a great day.
Thank you. Bye.